So let's start the session. Now, in the last class, we are discussing about the NumPy arrays, right? So in the last class, we are discussing about NumPy arrays, where NumPy arrays which is of nothing but for loop plus list. It is a combination of for loop and plus list. So where we are having a list, and for each and every element it is going to do. So NumPy arrays means NumPy arrays works on the element-wise operation. Element-wise operation. They are going to work on the element-wise operation. So for each element, it is going to execute. So for each and every element, it is going to execute. For miss, that is nothing but with respect to NumPy operations, where it is going to take the for loop plus list concept. Right now, how we are going to access this NumPy arrays that we have discussed in the last class, how to access or extract the elements. That is in terms of you can get the values by using a single value. If you want, means you can use by using the index number. If you want multiple values, means you can get through slicing operation or through list of index values. Whatever the index values you want, you can write the index values. You can repeat the index values. You can take the same index value. Choice is yours, right? Now, and you can get the values based on the condition also by writing one condition and the values which satisfies the condition. So you can extract the values which satisfies the given condition, right? Now, next, how to modify the values in the NumPy. Now, coming to the NumPy is also a mutable object, where NumPy is also a mutable object, similar kind of list, because it is created based on the list, right? Now, here we can add the elements, we can delete the elements, we can modify the elements. So we have seen how to access the elements. Now we are going to see how to modify the values within the NumPy array. How to modify means how to add a new value, how to delete a value or something, replace, right? So how to add a value means, for example, here a is equal to, I'm considering a is equal to np.arrange of 10 to 101 with an increment of 10. Means what is the meaning of this? 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Up to 100 you are going to get. This is an NumPy array. Now for this a, whatever the a is there, that is a is equal to 10, 20, 30, 40, 50, 60, 70, 80, and 90. This is the a value. Now with the a value, what I'm going to do, I'm going to append the 110. Means I'm going to add the number called as 110. So if you want to have already here, we are having in the a 100 also is there. Yes, 100 also is there. So a is having up to 100. Now what I'm going to do for this, I'm going to add the 110. Means I want to append. I want to add. Append means it is going to add the value at the end only. It is going to add the value at the end only, right? So we are going to add the value. Whatever the value of 110 is there at the end, we are going to add by using the append function. So it is going to add at the end. Similar kind of list. For example, if you want to add a multiple values, single value means write the single value. If you want multiple values means take a list of values. All the list of values will be added as a single value only in the array. It is not going to create the nested list inside the array. All the values will be added as a single array. Means append function and extend function in the list. For here in the NumPy, it is equal to extend function in the list. In the extend, if you are taking the multiple values in a list, what happens? Each value will be added. Similar way here also, it is going to add the single values, right? Next, if you want to replace the value, a of 5 is equal to 150. In a list, how we have replaced? Same to same. So for example, I want to replace a of 5, that is 0, 1, 2, 3, 4, 5. A of 5 means this one. 60, I want to replace with 150. Means this 150 has to be filled in the place of a of 5. So I'm going to fill a of 5. This one is 150. Okay, the 60 has been replaced with 150. Is that clear? Just in the list also, we have done the same. If you take a list of 1, 2, 3, 4, 5, and a list of 2 is equal to 90. If you take like this, what happens? Automatically, the number 3 will be replaced with 90. Same, whatever we have done in the list, the same to same, right? Next, how to replace the multiple values. In a list, we can replace only one value at a time. If you want to replace one more value, means we have to write in the separate cell. But here, I mean, separate line. In the separate line, we have to write. If you want to replace a different value. But replacing the multiple values in the single array, we can do with a easy way like this. Like a of 1, 5. First, a, this is a. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. A of list of 1, 5. Whenever you are accessing multiple values, simply remember multiple values means list of values. Multiple means list of values. Always fix. Multiple means single value directly. More than one value is there means then it is called as multiple values. Multiple values we have to use means list of values only we have to use. We can't use directly a of 1 comma 5 like this. We can't go. It will throw an error. Why? Because if you observe this one, a is an array. Okay, bracket. This first main square bracket indicates that you are accessing the index. This bracket indicates that you are accessing index, whether it is a list, whether it is an array, whether it is a tuple, whether it is a string, whether it is a pandas, whether it is an NumPy array, whatever it is, the main bracket indicates that you are working on the index. Now here 1 comma 5 means multiple values. You want multiple values. Whenever you want the multiple values, take the list of values. Right? So what happens here? The list of a of 1 comma 5, I'm going to fill with 800. Okay, multiple values are filled with 800. What are the list of values I'm going to fill? Miss a of 1 comma 5, that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 0 to 9, I'm having, these are the index numbers, out of which 1 and 5. 1 and 5 means this one, and 5 means this one. These both the locations of index numbers will be filled with 800. That is 20 will be filled with 800, and 150 also will be filled with 800. So now you are going to get an output like this: 20 and with respect to 150, whatever the 150 values. Is that clear? So list of values you can replace like this at a time. Here you can replace with a single value. This already we know. This is in the list. How we can, this already everyone knows. In NumPy array, we are having this facility. Just what it is going to do in the backend, for I in range of length of list, it is going to take length of list. Whatever the list is there, this is considering as the length of list. Okay, here whatever the index numbers you are writing, this index numbers, you want the list of index numbers, this one, right? 1 comma 5. So now it is going to check I. Inside that, it is going to take for I, for j in index, for j in index. If your I value is equal to your j value, if I value and j value, if both of them are equal, if I and j both of them are equal, then only that particular element has to be replaced. So it is what it is going to do. First I value will be 0. First I value is equal to 0, j value is equal to 1. No, it is not going to work. I value 0 and j value is equal to 5. No, it not work. Next, I value is equal to 1 and j value 1. Yes, I and j both are same. Now one value will be replaced. That is the backend code. So this for loop is the backend code. You don't need to focus on the backend. No need of Python. Core Python we don't require. Directly we are working on the NumPy arrays. So how it is going to work means, just it is going to fill the values wherever the index numbers are same. Just it is going to replace the values. Now you can replace with a single value, or you can replace with the multiple values also at a time. So that like this, a of 1 comma 5, 100 comma 800, or sorry 100 comma 200. I'm writing 200. Now what happens? A of 1 will be replaced. A of 1 means this is now a. This is the latest a. After doing the replacement, now this is the a. Now whatever the a of 1 comma 5, 1 comma 5 means within this a of 1 is this one. A of 5 is this one. So this is 1, 2, 3, 4, 5, 0, 6, 7, 8, 9. So now a of 1 will be filled with 100. A of 5 will be filled with 200. So just it is going to fill multiple values simultaneously. So this value was filled with 100 and this value was filled with 200. So you can replace multiple values with a single value. You can replace multiple values with a multiple values. But here, if you are replacing multiple values with multiple values, then number of index numbers and the number of values should be the same. Otherwise, for example, you are writing like this, comma 300 you have given. Assume the comma 300 also you have added. Okay, you have added the comma 300. Now what happens? A of 1 will be filled with 100. A of 5 will be filled with 200. Then what about 300? So it is going to throw an error. In this case, it will throw an error, that value error. You have to give only 2 values. Here I am collecting 2 values as the input. So what it is going to do in the backend, you know, A of 1 is equal to 100. A of 5 is equal to 200. This is the backend code. First value will be taken as first value. Second one will be taken as second one. Just multiple variable assignment it is going to do. A of 1 comma A of 5 is equal to 100 comma 200. If you give 2 values, if you give 3 values, what happens? Left side 2 values, right side 3 values are there. Multiple variable assignment, what happens? It will throw the error. Same thing, same. In the core Python, how we are going to get the error? Same way. See here, shape is mismatching because it is a one-dimensional array. Left side you are having only 2, right side you are having of 3 values. Mismatch of 3 and 2. Is that clear? Whenever you are writing that same numbers, multiple here 2 and here also 2, then only it is going to work. Then how we can delete a single value? I'm showing you how to replace, how to add a single value, how to add a multiple values, how to replace a single value, how to replace multiple values. Similarly, how to delete a single value, how to delete multiple values. How to delete a single value means just np.delete and write the array name, comma, index number, whatever the index number you want to delete. That is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I want to delete the index number 8. This part has to be deleted. So you're going to delete this one. Now automatically you're going to get balance. This part will be deleted. If you want to delete multiple values, write the list of index numbers 4, 6. Now what is the latest A value with respect to this? So that latest A value, it is going to remove the A, 6. Is that clear? That's it. Next, copy. Next example is copy. Now copy, we are having two types of copies. In the list, we are having two types of copies. The first copy is called as shallow copy. Second one is called as deep copy. Right? Shallow copy and deep copy. Deep copy means both of them indicates to the same object. Okay. Where A is equal to list of 1, 2, 3, 4. B is equal to list of 1, 2, 3, 4. Or simply if you say B is equal to A. B is equal to A means this is nothing but deep copy. Deep means both indicates on the same to same object. Both of them indicating to the same object. If you do modifications on one of the object also, it will be applied on the other object. Then it is called as deep copy. If it is creating a new copy, separate copy it is going to create. That is A is equal to 1, 2, 3, 4. And B is equal to A dot copy. If you write the dot copy, this dot copy comes under shallow copy. Shallow means shadow. Shadow means in terms of when in the list I have explained. Yeah, just can you change that one? Okay, shallow copy means dot copy. Dot copy comes with respect to shallow copy. Okay, dot copy is shallow copy. In the list or in the NumPy arrays, both of them, whenever there is a dot copy, please take it as shallow copy. Okay, guys, maybe I have made a mistake in the during the list, so please rectify that one. Okay, I'm sorry for that, and please rectify that shallow copy means dot copy. Dot copy, where this is also called as shadow copy, or for easiness understanding, or it is also called as Xerox copy. Shallow copy is also called as Xerox copy, where it is going to create a new object. Okay, completely it is going to create a new object, and whatever the modifications you have done in the A, it is not going to reflect in the B. Both of them are indicating to the different objects, two different objects. You can write shallow copy means A, B are two different objects, are two different objects. Where here A, B are identical objects or same objects. Okay, both of them are indicating to the same object. The modification in one of the object will be modification in one of object. In one object will be reflected in others. It will be reflected in others. Whereas modification here in the modification in one object will not be reflected in others. Will not be reflected in others because both of them are indicating to two different objects. Okay, this is called as deep copy and this is called as shallow copy. Dot copy is called as shallow copy, right? So here A is equal to np.array of 1, 2, 3. So B is equal to A dot copy. A dot copy means it is going to create one more object similar kind of this one. So where you are having 1, 2, 3, this one is A, and B you are having one more 1, 2, 3. This is B. Now in the B, what you are going to do, B of 0 is equal to 100. Means the first portion, whatever the 0th portion is that you are going to replace with 100. Now A is 1, 2, 3 as it is. B will be 100, 2, 3. Right? It is going to be 100 and 2, 3. So whenever you are using dot copy means it is going to create a new object. Remember this. Dot copy means creates a new object. Dot copy means you are asking a copy. Create a copy. You are asking to create a copy. Right? Now, next, sorting an array. How we are going to sort an array means by using np.sort. np.sort 4, 6, 8, 2, 1. Just you are asking here to sort the values in the ascending order. Just it is going to do the sort in the similar kind of list.sort. Whatever we are having list.sort, here also the same np.sort. Now, majorly, what is the use of NumPy arrays means this is the main purpose operations, NumPy operations. This is the main purpose of the NumPy. Now where we are having A is equal to NP dot array of 1, 2, 3, 4. Now this is the A value. A is 1, 2, 3, 4 now. Okay. Now what is A miss? A is equal to 1, 2, 3, 4. Now A plus 1. If you are doing A plus 1, what it is going to do means for each and every element, it is going to add plus 1. For each and every element, it is going to add plus 1. That is 1 plus 1, 2 plus 1, 3 plus 1, and 4 plus 1. Because in the backend, it is applying the for loop for I in A. Whatever the I value is there, I plus 1. I is equal to I plus 1 or J is equal to I plus 1. And it is going to create a new list L dot append of J and print L. This is the code, backend code. This is the backend code, out of which we required is I plus 1. Means for each element, we want to add plus 1. So it is just adding the plus 1 for each element. This makes very fast. Instead of writing these many lines, we can write just by using A plus 1. This is the main advantage of NumPy. Okay, in real life applications, why we use NumPy majorly? Because short, very short. It automatically applies the for loop, right? A into A to the power of 2. A to the power of 2 means for each of them, this is the A value. This is the A value, 1 square, 2 square, 3 square, 4 square. So now it is going to do the square of each of them. Now you may ask me the question, sir, already A plus 1 you have done, and here it is giving 2, 3, 4, 5, right? Now A is this one, right? Or this one. A is this one or this one means here A is still, it is this one only, because here you are asking just to do the mathematical calculation, but you are not storing that one. If you write the A is equal to A plus 1, then only it will store. Otherwise, it will not store, right? It is going to create a new one, new array, and it is going to display that one. Here it is just printing, because that it is in the last line, it is printing. Since it is in the last line of the Jupyter Notebook cell, it is printing, right? A plus 1 means for each and every element, it is adding the plus 1. A to the power of 2 means for each and every element, it is doing the square. Now, next, A is equal to array of 1, 2, 3, 4. And B is equal to 5, 6, 7, 8. This is 1, 2, 3, 4, 5, 6, 7, 8. A, B. C is equal to 1, 2, 3, 4. Again, C is equal to 1, 2, 3, 4. Print A means it is going to print 1, 2, 3, 4. B means 5, 6, 7, 8. C means 1, 2, 3, 4. It is going to print the arrays in this way. Okay. Now, A plus B. A plus B means for each and every element, for automatically for. So it is going to apply for each and every element 1 plus 5. That is 6. 2 plus 6, 8. 3 plus 7, 10. 4 plus 8, 12. So you are going to get output like this. The element-wise operation, it is going to do the element-wise operation. Okay, for each and every element. Sir, out of which, for example, this is having, one of them is having 5. I assume that 5 is also there. 5 values are there. B is having only 4 values. Okay, A is having 5 values. It can store. But A plus B, if you do the A plus B, it is going to throw an error because both of them are having different shapes. This will work only if both of them are having the same shape. Okay. So it works only if both of them are having the same shape. That is here number of elements here and the number of elements are here. Both are same. Then only it is going to work. Similarly, A minus B. A minus B means 1 minus 5 minus 4. 2 minus 6 minus 4. 3 minus 7 minus 4. 4 minus 8 minus 4. So it is going to give minus 4 minus 4 minus 4 minus 4. Right? Sir, can you explain the with for loop for A plus B? Yes. Just A is equal to list of 1, 2, 3, 4. B is equal to 5, 6, 7, 8. Okay, just you take for I. First, you consider this if condition. If length of A is equal to length of B, then only it has to work. If this is not true, it has to throw an else error. Else part is error. Now, if condition, if both the lengths are equal, then length of A is equal to length of B. Then what it is going to do means for I in range of length of A, for I in range of length of A. Okay, because both the lengths are same, length of A or length of B, anything you can consider as per your choice. Now, for I in range of length of A of I plus B of I. And this you are going to store in a new value, some kind of value called as J, and take a new list, empty list. And for this empty list, you are going to append n dot append of J. So now I is equal to 0. First it is going to take 0. A of 0 is 1. B of 0 is 5. So A of 0, A of 1, A of 0 is 1. B of 0 is 5. 1 plus 5, which is going to take 6. And this 6 will be appended here. Right? Again, from here, again, it will come back to here. Not it will not go back here up to for loop only. It will back to here only. After from here it will go back to here. Now I is equal to with respect to 1. 0 is completed. Now 1. A of 1 is 2. B of 1 is 7. 2 plus 6 which is nothing but 8. So first value is 6, second value is 8. Next 2 is also completed. Next 3. So A of 3 plus B of 3. Like this, it is going to take for each and every elements and it is going to add. And finally, I'm printing the n value. Print n value as the output. Is that clear? So that is the code. If both of them are equal only, it is going to work. If both of them are not equal, means it will throw the error. Right? Yes. Similarly, A minus B. And similarly, A into B. If both of them are equal only, the element-wise operation means 1 will be multiplied with the 5 only. 2 will be multiplied with 6 only. 2 is not getting multiplied with 5 or 2 is not going to multiply with 7. So element-wise, the same position value will be multiplied. That is, if you remember, okay, that we'll discuss later. First, let us complete the one-dimensional array that we'll see in the two-dimensional arrays. Another example. So 1 into 5, 5. 2 into 6, 12. 3 into 7, 21. 4 into 8, 32. So this is the output. Once you execute this code, A into B, you have to get the answer as 5, 12, 21, and 32. Right? So element-wise operation. Next, comparison operations. Okay, A double equal to B. Now it is going to check this A, array of A. That is A is equal to 1, 2, 3, 4. Array of 1, 2, 3, 4. B is equal to array of 5, 6, 7, 8. C is equal to array of 1, 2, 3, 4. Now it is going to check whether A is equal to B. Comparison operators. Comparison operators means it is going to compare between the values where A is a list. It is a array. Array means element wise. So element wise it is going to check. 1 is equal to 5. False. 2 is equal to 6. False. 3 is equal to 7. 4 is equal to 8. It is going to check element wise and it is going to give the output. Element wise operation. Okay. Similarly, A is less than B. A is less than B means 1 is less than 5. True. 2 is less than 6. 3 is less than 7. 4 is less than 8. Element wise operation. It is going to do element wise. Sir, I don't want element wise, sir. I want to check overall. Overall complete array and this complete array is same or not. That I want to check. Then we are having array underscore equal. This equal to symbol is element wise operation. This array underscore equal is the function is overall array, complete array. This complete array and this complete array both are equal or not. It is going to check. That is the difference between these two. This is element wise. This is overall wise. Okay. Now, if you want to check overall A and B are equal, overall, each and every element of A and each and every element of B, everything are satisfied only, then only it is going to print true. If one of them is different, also false. So each and everything are same? No. So it is going to print the false. Overall, it is going to check overall. np.array of equal of A comma C. That is every element of A and every element of C, everything are equal. Yes, everything are equal means true. So in the backend, what it is going to do, just it is going to apply the same logic of A is equal to C. True, 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 true. All of them are true. That is, it is going to keep the end condition in between them. If everything are true means, what is the output? Finally, true only. So it is going to print that one. Element wise operation in between end it is going to keep. For example, A is equal to 1, 2, 3, 4. Not list, array of 1, 2, 3, 4. Let us take A is equal to array of 1, 2, 3, 4. B is equal to 5 and 2, 3, 4. 5, 2, 3, 4 is there. Now you are asking array underscore equal of A comma B. Now it is going to check false and true and true and true. Overall it is false. The output will be false. If you ask like this, array underscore equal, automatically in between end operation it is working. Logical operation of end it is going to execute. Is that clear? Now, next, mathematical operations. So we have seen with respect to some kind of arithmetic operations like basic operations, A plus 1, A into 2, powers, all these things. Arithmetic operators, I have applied plus, minus, into, like this, arithmetic operators. Now I'm applying the comparison operators. After that, now mathematical operators. A is equal to np.arrange of 0, 6. What is meant by that? 0, 1, 2, 3, 4, 5. Arrange. Arrange means array. It is going to create array. An array of 0 to 5. Okay, done. This is A value. Now for this np.sign A. Sign A means sign of 0, sign of 1, sign of 2, sign of 3 for each and every element wise operation. NumPy means element wise operation. Every time fix. Okay, so for each of them, it is going to calculate the values. Sine 0 is 0, sine 1 is 0.84, sine 2, sine 3, sine 4, like this. Okay. Similarly, np.log, log of 0 is infinite. So it is going to print the infinite and it is going to throw the warning also, stating that there is one of the thing is infinite is available. Log 1 is 0, right? Similarly, we are having with respect to the values like this for log 2, log 3, log 4, and log 5. Next, np.exponential of a. np.exponential of a is e to the power of 0, e to the power of 1, e to the power of 2, e to the power of 3, e to the power of 4, e to the power of 5. Log of 0, log of 1, log of, for each of them, just it is applying the, for each and every element, it is applying this one. Whatever the array is there, it is applying this one, right? So log of 0 and log of 1, log of 2, log of 3, log of 4, log of 5. Now e to the power of 0, e to the power of 0 is 1, e to the power of 1 is 2.71, e to the power of square is 7.82, something like this. It is going to print. E to the power of 0 is 1, e to the power of 1 is 2.71, e to the power of 2, just nothing but e to the power of 2 is nothing but e square, right? E cube, e to the power of 4, e to the power of 5. Is that clear? So these are the some of the mathematical operations, right? Till now we have worked only on the one dimensional. If you observe all these things in the last class, how to replace the values or sort function, delete function, all these things we have worked only on the one dimensional. Till now, whatever we have done is only one dimensional, no two dimensional we have worked. We have seen with respect to how to access the multiple values through the indexing. Everything now, till now we have worked on the list. A simple list with a for loop we have applied and which is called as one dimensional array. We have discussed. A one dimensional array, in a simple word we can say one dimensional array is equal to for loop plus list. In a list we are applying the for loop concept and we are appending every time. Whatever the output we have got appended, that appended answer we are printing as the output of the array. Okay, till now we have done this one. Now we are moving on to the two-dimensional. Next concept is two-dimensional arrays, where in the two-dimensional arrays we are having a nested list, whereas each list is considered as one row. One list is equal to one row. So this is the main list. Okay, within the main list you are going to take the nested list. Nested list of each value should be a list only. Inside that everything should be list only. Sir, for example, I'm having one value only, sir. Take one value as a one list, but it should be in the list only. Okay, but it should be in the list only, right? So here, what I'm going to do, so here the nested list, the main one, the main list, within that first one is 0, 1, 2. This is the first item. First item will be considered as the first row. Second item will be considered as the second row. Third item will be considered as the third row. That is 6, 7, 8. If you're writing like this, third item will be considered as third row. For example, you are having only two items, two rows. You are going to get with respect to two rows. That is 0, 1, 2, and 3, 4, 5. Now the question is, of course, just now we have completed with respect to this two-dimensional, but immediately the students will get a doubt. Sir, here if I'm having only two values, here I'm having three values, then what is the thing? Okay. First, they will get the question. After that, they'll understand the concept. First question will come. After that concept, they will understand, right? So just we'll remove this, whatever the two is there, just we'll remove the two and we'll execute. Now what happens? It is considering as a list of values. It is not considered as an array of values. Both of them should be the same. The number of items, the number of values in the each list should be the same. Otherwise, you can see the answer that it is showing as a list. NP dot while creating this one. So here clearly you can see it is throwing an array that we can't create this one by using these two like this, right? So it is just concatenating. Concatenating is possible, but adding is not possible. Creating a two-dimensional array is not possible. So when we are having this one, so generally we'll go with the number of elements in the both the list of values should be equal. If you give in one of them more also, it is going to take the error, same error. Once again, you are going to get the same error if both of them are same only. So please go slow, not able to get time for writing notes. Guys, offline students, same. Guys, each and everything detailedly you have to write in the notes slowly, one by one, step by step. Means automatical data science overall it will take 1 year or 2 years of time, right? So just to focus while I'm explaining, and whichever the important point running notes is that only you write. And after the class, while practicing, you write detailed notes. Then practice will be done, notes will be done. In the class only, I have to explain each and every point detailedly, slowly explaining and writing means automatically it will take so much of time. If I'm having that much of time of 2 years of time is for data science, surely I will do that one only. At least I'm having 1 year of time also, I will use to do that one only. But in 4 months only, we have to do everything, right? Now, so here we are having with respect to the number of elements should be the same. Just focus means no need to write, just focus. And whichever the important point or running notes, whatever you can do, that running notes only write. Not in each and every detailed point. A detailed point you can write after while practicing, right? Now this, if you ask the NDIM, if you check in the one-dimensional array, whatever the one-dimensional array we have done earlier, if you see here, A is equal to one-dimensional array, NDIM, I asked her. So here I have got the 1. So now the same NDIM concept I'm going to apply. Now by using the NDIM, now I'm going to get it is as a 2-dimensional. Why it is a 2-dimensional? Because we are having with respect to multiple rows are available. Sir, here one more row. Let us take one more row. One more row also, one more list. Each row is each list. How many values should be there in this list? 3 values. Any 3 values as per your choice. For example, I'm writing 34, 58, 96. 3 values. So now still it is a, sir, 3 rows are there. No, sir, it is 3-dimensional. No, it is 2-dimensional. Number of rows and number of columns, right? So here it is considered as a 2-dimensional only. And what is the shape means? 3 rows and 3 columns. So it is going to throw 3 by 3. The shape is 3 by 3. Now it is going to show the second number. In the shape, you are able to see the second number means it is the meaning is 2-dimensional array. If the shape shows only 1, 3 comma like this, then it is the indication of 1-dimensional array. 3 comma 3 or 3 comma second number, one number you are seeing in the second position. That position is called as with respect to 2-dimensional. If you are able to see one more value like this, or whatever the value, don't focus on the value. If you are able to see one more value, then it is a 3-dimensional. The shape will be like this, right? Now here, for example, I'm having 3 rows, 3 columns. Instead of 3 rows, 3 columns, let us go with the 2 rows and one more bracket. Okay. Now 2 rows and 3 columns, 2 by 3. Now np.zeros. np.zeros means earlier we have created np.zeros using the 1-dimensional array. Now I'm going to create by using the 2-dimensional array. Just you have to give the shape as a 2-dimensional, 2 by 2. 2 by 2 means 2 rows, 2 columns. That is 0, 0 and 2 columns. Again 0, 0. Array. 2-dimensional array will be indicated with double square bracket. Right? The only difference, sir, what is the difference between a nested list and array? In the nested list, the same thing will be represented as 0, 0, 0, 0. This is nested list. Array will be represented in this way. Same brackets. Total 1, 2, 3, 4, 5, 6. 6 brackets are there. Here also 6 brackets will be there. Same to same brackets. The commas will be erased. The commas will not be there. Whether it is a 1-dimensional or 2-dimensional, in the list, if you remove the commas, it is the representation of array. If the same thing you are representing like 1, 2, 3, 4, if you write, if in the notes, if you write like this, it is considered as a list. If the same thing, if you write in the notes like this, then it is considered as an array. Right? Just if you remove the commas, it is considered as an array. Right? Now, here np.zeros of 2, 2 means 2 rows, 2 columns. 2 rows and 2 columns. 0, 0, 0, 0. np.ones and np.zeros. In the both of them, just in the bracket, you have to write only the shape. Whatever the shape is required, that is the syntax. Inside that, you have to give the shape, whatever the shape you require. If you have given 1-dimensional shape means, it is going to give the 1-dimensional output. 2-dimensional shape means 2 dimension. 3-dimensional shape means 3 dimension. 4-dimension means 4 dimensions. Okay. So here, if you write 2 comma, just you have written only 2 comma. 2 comma means what this bracket indicates. This bracket indicates for the function. The main bracket, whatever the main outer bracket is there, that is zeros function. That bracket function. This inner bracket 2 comma is there, right? This is the shape. Representation of shape. Shape will be represented in a tuple. The shape will be taken in a tuple, right? 2 comma means 1-dimensional shape. You are going to get only 2 values of 1-dimensional array. Whereas 2 comma 2 means you are going to get 2-dimensional of 2 zeros, 2 rows and 2 columns. If you write one more, for example, I'm writing one more comma 3. I'm writing 3 comma 3 means 3 dimensions. Now, if you observe this one, see, can you see this? It is a 3-dimensional body where we are having 3 open brackets. Can you see? 3 opening brackets will be there. What is the difference? If you want, you can see the difference like this clearly. np.zeros of, I'm writing 2 comma 1 or 2 comma only. Just I'm writing 2 comma. Now, np.zeros of, again in the bracket, I'm writing 2 comma 2 something. Okay. Now, if you observe for one dimensional array, how many opening brackets are there? 1. For two dimensional array, how many opening brackets? For three dimensional array, based on the opening brackets only, we can say that it is one dimensional array or two dimensional array or three dimensional array. At the starting of the first brackets only, we can identify that one, right? So that is one of the easy way to identify, right? So now what happens here? It is going to create a three-dimensional. What is meant by three-dimensional? Multiple two dimensionals is called as three dimension. In this room consists of how many two dimensions? In front of you, whatever the wall you are seeing, the board, whatever you are seeing, the front wall is a two dimension. The side wall, you can see the wall, right? With length into breadth. This is also one two dimensional. Back side wall, left side wall, top side wall, and downside. Downside also you are having length into breadth, right? It is also rectangle downside. Total 6 faces are there. This is a cuboid. Whatever the classroom we are having or whatever the house, for example, online students are attending from their home. In their home, whatever the room they are sitting also, it is a cuboid only. Either it is cube or cuboid. Cube means if everything is same means then it is called as cube. If one of the length is different also, it is considered as cuboid. Where cuboid or cube, everything is a three-dimensional. What is meant by three-dimensional? Means multiple two-dimensionals. Multiple two-dimensional object is called as three-dimensional. For example, this one only if you consider, this is a three-dimensional, right? Where this three-dimensional, if you whatever you are seeing the front face, this is the two-dimensional. If you see from this side, this is also a two-dimensional side part of this one. If you see back side, this is also one two-dimensional side part. This is a two-dimensional side. This one two-dimensional. Like this, multiple two-dimensional. 6 faces are there. Overall, this is also one of them. Like Rubik's cube. Rubik's cube also three-dimensional, where multiple two-dimensionals are there. Multiple two-dimensionals is called as a three-dimensional, right? Multiple three-dimensionals is called as four-dimensional. Multiple four-dimensionals is called as five-dimensional, right? Is that clear? Just for example, np.array of only 42 you have taken. First example. What is this? What is the dimension? It is a 0 dimension. Multiple 0 dimensions means multiple single values is called as one dimension. That is np.array of list 42, 41, something like this. Here, what is the difference between this one and this one? Here a single value is there. Here the same single values, multiple values are there. Multiple single values is considered as one dimension. Now two dimension is multiple list. This is one list. Take one more list. It is two dimension. Multiple like this you take. Multiple combination. So this is one two dimensional. This is one two dimensional. It is called as a three dimensional. Multiple two dimensionals is called as three dimensionals. Right? Is that clear now? Similarly, here np.ones of 2, 2. 2, 2 means 2 rows and 2 ones. 2 rows and 2 columns. Next, we are having with np.i. np.i. This is not having with respect to one dimension. It is having with respect to two dimension. That for two dimension, I means identity matrix. Identity matrix. So 3 by 3 identity matrix. What is meant by identity matrix? The diagonal element should be 1 and remaining it should be 0. Is called as identity matrix. So this is going to create an I array, which is of 3 by 3. So 3 by 3 means it is going to create like this. Sir, instead of 3 by 3, for example, I'm having again common doubt. Sir, here if I give the 2 by 3, what happens? Yes, it is going to create 2 rows and 3 columns. 2 rows and 3 columns means this will not be there. These two will come like this output. You'll get output like this. But here, if you see here, tuple cannot be interpreted as an integer. So is that clear? This is the syntax. Here you have to give the syntax not with an input as shape. So if you open the syntax for I, the syntax, what is the syntax for I? What is the syntax for this one and what is the syntax for this one? You observe np.ones, what is the syntax it is asking? Shape as the input. Shape you have to give as the input. If you want to expand, click on this. Now you can see here shape. Shape should be either int or a sequence of int. Int when, for example, if you write np.ones of 1 or 3, single int, only you have written int, not with respect to you have not given any shape. You have given just only 3. It is accepting the single int also. It is going to print the one dimensional array of 1, 1, 1 like this. If you want, you can see. Okay, by default, it is going to take as one dimensional. If more than one dimension, if you want, then in the second case, you have to provide the sequence of int. Sequence of int means you have to provide with the shape of with respect to 3, 3. Okay, so you are going to write 3, 3. So this function was created by considering the values. If it is a single value means One dimensional array, if it is multiple values means according to that shape, it is going to work. Now this function was created in that way. Now this function was created with by considering the first letter n. What is meant by n? I don't know. N means number of rows. How many number of rows you want in the output? N means number of rows, it seems. M is number of columns in the output. So for example, if I'm writing only n, out of which compulsory arguments, how many compulsory arguments are there? Only n is the compulsory. M is not mandatory. If you don't give n also, m is not mandatory. So I'm going to give only 2. Automatically, what it is going to do? By default, it is going to consider the square matrix. 2 by 2. Automatically, it is considered. By default, it is considering the, because identity matrix means by default, it is a square matrix. You want a special one, 2 rows with 3 columns means you have to write that one, whatever you require. By default, it is a square matrix. This function, sir, it is considering n and m number of rows, number of columns. How I can know all these things, sir? Means we have to read. How you can know means we have to read. Any function within the Python, any function is there means that function we have to understand means we have to read the help file. Whoever has created that one, we have to read that one. Without reading or without learning, how we can understand? In the English word, there is an English word called as tomorrow. What is the meaning of tomorrow, miss? You have to understand what is the meaning of that one, miss. You have to read that meaning, right? You have to learn that one, right? Without learning, how I can use the tomorrow, sir? How I can remember tomorrow, sir, miss? You have to learn, you have to practice, then you can use wherever it is applicable. Where you are going to use tomorrow? In which case you are going to use tomorrow? Whenever you want to explain with respect to tomorrow or what happens, something you want to explain, then in that situation, you are going to use the tomorrow word. Other situations, you are not going to use. Simple. Is that clear? Now, if you observe here, the data type, the output, you are going to get 1 dot, 0 dot, 0 dot, something like this. Some students will ask me the question, sir, why we are getting this type of dot? It is not, dot is not important for us, but still, if you feel that dot, why here and here it is showing the dots miss. If you're not interested in the float, by default, it is considering the data type as float. If you're not interested in the data type as float, you can take that one as int. If you write int, then automatically it will show the int only. Here also the same data type. If you write the data type is equal to int miss, it is going to show int. By default, it is taking as float as the data type. By default, float. Default parameter is float. If you open the help file, here the data type, whatever the data type is there, data type is an optional. The desired data type for an array, if whatever the default is float, it is going to consider float. Now, next question is, sir, here there is a float 64. What is meant by 64? 64 is with respect to number of bytes of space it is going to use. So here it is not important for us. You don't need to focus on the number. Just int miss, integer, float miss, float value. This number 8, number 64, all these things you are going to learn when we are expanding the database. Because this software was designed along with the database also, right? Some data and backend, some memory, and something has to be created, right? In the memory, it has to allocate some memory and it has to use that space. Means how much space it has to use. In the memory, for example, your 8 GB RAM is there. In the 8 GB RAM, how much amount of space has to be used for this? Okay, that amount of space, all these details we are going to learn during the database. Okay, when we are discussing the database. Now, as of now, data type, if you want to get as int miss, you write as the int. If you don't write int, if it is 2 by 3, if it is float also, for us, no problem. If it is float also, no problem. In the situation, wherever just for example, we are adding, let us assume we are adding 2 matrices. The first matrix is 5, 6, 7, 8. The second matrix is np.i of 2, np.i of 2. Okay. Now here, this one you have created by using np.array. This array you have created by using the array of 5 and 6, comma 7 and 8. This you have created. Since you have created automatically, this is in the int tag. This one you are going to use the function called as np.i 1.0, 0.0, 0.0, 1.0. Okay, it is showing some kind of float. Now you are using the plus symbol. If you are using the plus symbol, what happens? Output is going to be 5.0, 6, sorry, this is 6.0, 6, 7.0, and 9.0. You are going to get like this, the output. Right? You are going to get output like this. Now, if you get the output like this, or if you are getting the output like this, what is the difference for us? If you are working only on the numbers, our requirement is numbers miss, then what is the difference? If you are focusing on the data type, then that is important. If you are focusing only on the numbers and we are doing the mathematical operations, in that case, whether it is 0.0 is there or not there also, for us, no problem. As we all know that 4 is equal to 4.0. If you compare value wise, data type, both are different. Value wise, both are same, right? Now np.dag of 1, 2, 3. There is one more function called as dag. Now this is going to create, these values will be considered in the diagonal elements. 1, 2, 3 is the diagonal elements, automatically remaining thing. Okay, this is considered as the diagonal elements. By default, it is going to take automatically the square matrix. Automatically, because the diagonal elements cannot be with respect to uneven. You can't get the shape by using 2, 3. Right? So dag is 1, 2, 3. Miss, you are going to get like this. Done. Next, np.array of 1, 2 and 0, 4. This is 1 and 2. Next one is 0 and 4. Okay, this is an array. Now, for this array, I want to extract the diagonal elements. This is np.dag of, you have given the values and it is going to create the diagonal matrix. Already diagonal matrix is available. For that, it has to extract the diagonal elements 1 and 4. It is going to take the 1 and 4. Same dag function. Dag is not going to change. Within the dag, if you have given the values miss, it is going to create an array. If you give an array, it will extract the values. Dag function, if you give as the array, if you have given the 2-dimensional array miss, it will extract the diagonal values. If you have given the values miss, it is going to create a 2-dimensional array by using the diagonal values. Whatever the diagonal values are there, by using these diagonal values, it is going to create a 2-dimensional array. Inside this, you have given the values, you have given an array. It is going to consider that one. Miss, it is going to check if A is equal to A dot D type. It is going to check the type of A. If the type of A is equal to array, if it is array, it is going to extract the diagonal elements. Yes, Elif, type of A, whatever the input you have given, this input, if it is equal to list of values, according to that, it is going to create a 2-dimensional array. In the backend, if and elif was there. Is that clear? Based on the type, whatever the type you are going to give as the input, right? Sir, how we are going to use this np.I zeros and ones? Yes, during the matrices, when we are working on the matrix, at the time we are going to use this np.1s, np.2, np.zeros, np.I, np.dag. All these things are matrices when we are going to work on the matrix. Okay, so where in the matrices we are having the null matrix. Next one is identity matrix, unity matrix, diagonal matrix, right? So whatever we are having, these matrices, for those matrices to create, these are the various functions. For creating null matrix, we are having np.zeros. For creating identity matrix, we are having np.I. For creating unity matrix, we are having np.ones. For creating diagonal matrix, we are having np.dag. Okay, these are the only matrices which we are having. In the matrices, we are having only this. Apart from this, square matrix, as everyone knows. Okay, right? Now, is it clear? Yeah, dag is nothing but, what is meant by dag? Dag means nothing but, it is going to extract diagonal elements. Dag means diagonal elements. Diagonal. So here, whatever the diagonal elements are there, these values will be extracted here. If you have given the values means, using the values, it is going to create the diagonal like this. These values are used to create. Here in this case, it is extracting the values. If you have given the array as the input, np.dag of A is a list, A is array. So A is array. If it is array, it has to extract the diagonal values. That too, it is a 2-dimensional array. If you give as a 1-dimensional array, it will throw the error. If it is a 2-dimensional array only, it will extract the diagonal values. Whatever the diagonal values we are having. Sir, let us assume here we are having 1, 2, or something like this. 1, 2, we keep as this 0, 4, and next we are having 5 and 6. I'm practicing myself with one more example. This is called as practice. Instead of opening a new textbook or some other textbooks and some other material, I will do myself. I will create my own example. So now I'm having like this. Now where the elements of, I'm having 3 rows and 2 columns, 3 by 2. Now if I'm applying the dag, now what happens? Diagonal elements I'm going to get with respect to whatever the diagonal elements are there. Here the diagonal element is not there. So these two only I'm going to get. So dag is going to work irrespective of the square matrix or non-square matrix. DAG is going to check only whether it is a two-dimensional or not. Just it is going to observe whether it is a two-dimensional. If it is a two-dimensional, means extract the values from the diagonal. Though it is a square matrix also okay. If it is not square matrix also okay. This conclusion I'm going to write in the notes. Okay. So in the class, sir has explained up to here only. He has not explained this question to me. While when I'm the student, my professor has not explained this to me. I will not ask my professor, sir, if I keep that 5, 6, sir, it will extract. I will not ask like this type of silly questions. Once sir has explained, my professor has explained in the class this example. After the class, we'll practice, right? While practicing, first, directly I will not go and practice directly. I will not feel myself that I understand everything. First, I will do the revision of the same example. Whatever the professor has told me, the same example I will try, and I will write the notes. In my notes, I will write that, okay, this is the DAG function is going to take. So first I will open the help file. I will open the help file. In the help file, here V is the letter is there. What is meant by V means? V is a two-dimensional array, returns a copy of the diagonal elements. Okay, the same thing I will write in the notes. If two-dimensional array is given as input for np.dag, then it will extract the diagonal elements. It will extract the diagonal elements. And these diagonal elements will be stored as a one-dimensional array. Whatever the extracted values are there, it is going to create as one-dimensional array. If I store these values, A is equal to, now if I check the A value, yes, A it is getting stored, means the output it is returning. It is not printing, it is returning. So whatever the output it is returning, the function is returning the value. It is not printing the value. It is returning. So when it is returning the value, we can store. When it is printing, we can't store. For example, can you store the print 2? Okay, I have written the print 2. Print 2, can you store this print 2 in the A? A is equal to print 2. Now, what is the A value? If you ask A value. So here, in this case, whatever it is printing, so we can store the print value. But earlier versions, we can't do this one. This is the latest version where we can even store the print values also. But here, whatever it is returning. So in my notes, what I am going to write means, just it is going to return. It will return the, it will return the one-dimensional array. It will return as one-dimensional array. The output I'm going to get as a one-dimensional array, right? Where? Print 2. Yes, print is here. If you don't write this one, it will not store. The value will not be stored, right? So now, for example, if instead of this two-dimensional, if I give as one-dimensional, let us write as one-dimensional. I'm giving as input as one-dimensional, and I'm asking to extract the value np.dag of A. So now what it is going to do for one-dimensional, it is considering these values. I have written one-dimensional. Since it is a list of values are there, it is creating the two-dimensional. The output is two-dimensional. I'm giving one-dimensional means the output is two-dimensional. So if I'm giving the list of values means it is going to create a diagonal matrix. If I'm giving the diagonal matrix as the input means it is extracting the values and I'm going to get as a one-dimensional array. Is that clear? Next, np.array of 10, 20, 30, 40. 10, 20, 30, 40. Now, how to extract the values in the two-dimensional array? How to create the diagonal and how to create we have completed. Yesterday's class also what we have done. First, we have understand one-dimensional, what is meant by one dimension and how the shape of one dimension will be there. After that, what are the various functions for creating one dimension we have seen. And after that, how to access one-dimensional elements we have seen. Same way, here also we are going to do the same. For two-dimensional arrays also, I'm going to do the same. First, I have shown you what is meant by two-dimension, what is meant by n-dim and shape, and what are the various functions are used for creating a two-dimensional array. And now I'm going to work on the how to extract the value in a two-dimensional array, how to extract the value. So here I'm having with respect to a two-dimensional array like this. That is 10, 20, 30, 40. It is a two-dimensional. Now here in this two-dimensional of 10, 20, 30, 40, print A. Print A means it is going to print the two-dimensional, out of which 1, 1. Now here the row index number of 1, column in second row index is 1, 0 and 1. So here it is having with respect to row index and column index also. Earlier for one-dimensional, if you go with the one-dimensional of 10, 20, 30, 40, you are having 0, 1, 2, 3, 4. Only this one is there. Now you are having with respect to 10, 20, 30, 40. You are having a two-dimensional. Out of for two-dimensional, for row you are having index numbers along with the columns also you are having the index numbers. So this one is a of 0, 0. This is 0, 1. This is 1, 0. This is 1, 1. As everyone knows, in the matrices we have worked on Aij, right? But there it is with respect to first row is considered as number 1 only. It will start directly with the 1 only. Here the index number start with the 0 in Python. The only difference is that one, right? Now here a of 1, 1. A of 1, 1 means 40. It is going to extract the value of 40. So print a means a is printing, and value of 1, 1 means it is going to print the 40. Now this 40 I want to replace with 25. So this value will be replaced with 25. We are going to get 25 in this portion. The 40 is replaced with 25, right? Now, if you want to convert a 2-dimensional array to 1-dimensional array, we are going to use a concept called as flattening. One of the most important one. Most important one. The concept is called as flattening. Right? Flattening means converting the higher dimension to 1 dimension, converting an ND array to 1-dimensional array. Though it is a 3-dimension also, it will convert to 1. 4 dimensions also, it will convert to 1. Any dimension will be converted to 1 dimension. Just it is going to take each row followed by second row. Row wise, it is going to fill the values by row wise. Okay. So here I'm having with a 2-dimensional of 0, 1, 2, 3, 4, 5. So if I apply the function called as ravel, ravel is the function name. A dot ravel is the function. Function name is called as ravel. Concept name is called as flattening. Flattening is the concept name. Flattening means doing the flat, keeping everything on the flat surface. Just it is doing the flattening. Function name is called as ravel. Ravel is the function name. Okay. A dot ravel. Now by using that a dot ravel, now just you are going to convert this 2-dimensional array to 1-dimensional array. So if you want, you can check first print A. If you want, you can check the print A. Print A, it is going to give the 2-dimensional array, and after that a dot ravel has converted this one to 1-dimensional array. Right? Next concept is called as reshape. Again, one of the important concept. Reshape. Next concept is called as reshape. Right? Now, np dot arrange of 6. np dot arrange of 6. That is nothing but 0, 1, 2, 3, 4, 5. This is ARR. Print ARR means it is going to print 0 to 5 like this. ARR dot shape. What is the shape of this one? It is a 1-dimensional. What is the shape? How it is going to indicate? 6, comma. 6 is the number of values and comma. So it is going to give the output of 6, comma. Right? 0, 1, 2, 3, 4, 5 and 6, comma. Now what I'm going to do, ARR dot reshape of 2, 3. 2, 3 means 2 rows and 3 columns. Now 2 rows and 3 columns. 2 rows and 3 columns. This is the, now total how many values are there here? 6 values. Now here also 6 values are there. If both the values are matching only, it is going to execute the reshape. So here 2 into 3, 6, and here also we are having 6. Both of them are same only, it is going to execute. And first it is going to cover the first row followed by the second row. Row wise operation. It is going to do the row wise operation. And it is going to print like this. Sir, for example, you are asking instead of 2, 3, 2, 5. 2, 5 means 2 rows and 5 columns. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Total 10 values should be there. Here, how 10 values are there? Only 6 values are there. 6 values, how you can fill in the 10 positions? It is not possible because 0, 1, 2, 3, 4, 5. These 4 will be empty. So it is going to throw an error. It will throw an error that both of them. I can't reshape of 6 elements into 2, 5. It is not possible in 2, 5. It is possible in 2, 3 or 3, 2 or 6, 1. So 2, 3. 3, 2, 6, 1 or 1, 6. These are the possibilities. So if, out of these possibilities, every possibility is having the 6 values. So here if you ask 2, 3, first I am trying with 2, 3. Yes, 2 rows and 3 columns. 3, 2. 3, 2. 3 rows and 2 columns. Next, 6, 1. What is meant by 6, 1? 6 rows and 1 column. 6 rows means each row. This is first row, second row, third row, fourth row, fifth row, sixth row. First row 0, 1, 2, 3, 4, 5. Each row is one list. So this is one. This is overall it is a 2-dimensional. So it is going to print in this way. The output will be in this way. Is that clear? Or 1 comma 6. 1 comma 6. What is meant by 1 comma 6? 1 row, 6 columns. So you are going to get 6 columns. 1 row with 6 columns. Right? So if you observe this one, it is a 2-dimensional array. It is not 1-dimensional array. 2 brackets are there, not 1 bracket. If this is having only one like this means 1-dimensional array. If this was added like this means it is a 2-dimensional array. This is most important concept. Write in the notes. 100% you have to write in the notes. 0, 1, 2, 3, 4, 5. If you are having only one bracket, it is called as 1-dimensional array. The same values as it is if they are in the 2 brackets, then it is called as 2-dimensional array. Out of 2-dimensional array, this is the first row with 6 columns. Each list is a row. Each list here, how many lists are there? One list only is there. That list consists of 6 values. So it is a shape of 1 comma 6, 1 row with 6 columns. Here, what is the shape means 6 comma. This is the shape. This is the shape of this one. This is the shape of this one. Most important one. Right? In the machine learning, once the model was designed and we want to predict the values, if you want to predict inside that, we have to give as a 2-dimensional array, not as 1-dimensional array. We have to give input as a 2-dimensional array. Otherwise, it will throw an error. Okay. Now here, A is equal to np.array of 0, 1, 5. 0, 1, 5. 10, 58. This is 1 dimension and this is one more dimension. Now, A dot, now first you ask what is the A dot shape? First you print the A value. This is the A value. And if you ask A dot shape, what is the shape? 2 rows, 3 columns. It is a 2 rows, 3 columns. Now these 2 rows, 3 columns, I'm going to convert to 3 rows, 2 columns, which is called as reshape. I'm going to reshape to 3 by 2. Now, whenever you're asking a 3 by 2 reshape, first what it is going to do is, first it will do the flattening. 0, 1, 5, 10, 58. After doing the flattening, now it is going to apply the 3 by 2. That is 3 rows and 2 columns. 0, 15, sorry, 0, 1, 5, 10, 58. It is going to fill in this way. It is going to give the output in this way. 0, 1, 5, 10, 50, and 8. First, it will do the flattening to 1 dimension. After that, it will do the reshape. Sir, here, whatever I'm having, 0, 1, 5, 10, 58. This entire row you can take like this, right? 10, 58. You can take like this, right? This is also 3 by 2. Why you are considering like this? This is called as transpose. This is called as transpose. Rows are converted to columns and columns are converted to rows. Means it is called as transpose. The next concept is called as transpose. If you ask A dot transpose, then automatically you'll get the output as like this. This is called as transpose and this is called as a reshape. That is the difference between these two. Is that clear? So whenever you are asking the reshape, remember automatically first it will convert to 1 dimension, then only it is applying. First it will fill the rows followed by columns. Each row will be filled. First it will fill the row, not column wise. It is not going to fill the column wise because arrays are created based on the row wise. Because nested list means each list is considered as a row. So first row is the priority. Is that clear? Next one is sort. Sir, now again 5, 4, 6, 2, 8, 2. You are having this one 2-dimensional array. Now I want to sort. How you want to sort? With respect to column wise sorting or row wise sorting? Column wise sorting. If you do the column wise sorting, column sort. Now out of these 2 columns, which is the least value? 2. So 2 and 5. Out of these 2, 4 and 8. Out of these 2, this is called as column sorting. Column wise, each column you are seeing the which is the least value. Column wise you are doing. This is called as column sort. If you do the row sort means it is going to execute on the row wise. Out of this row, what is the least value? 4, 5, 6. In this row, 2, 2, 8. If 2 of them are same means if you write that one before also, both are same. No difference. Okay. Now this is called as row sort. This is called as column sort. Now how we can apply the row sort and column sort means axis. We are going to use the word called as axis. Okay. By writing the axis is equal to 1, it is called as row. Axis is equal to 0 is called as column. Now, whenever you have written here np.sort of A, axis is equal to 1. Now, what is meant by axis is equal to 1? Row wise. It is going to check in this row, which is the least one, and row wise sorting it is going to do. That is 4, 5, 6, 2, 2, 8. You are going to get an output like this. For example, here instead of axis is equal to 1, you have written axis is equal to 0. Then it is going to do the column wise sort. Each column wise it is doing the sorting. Is that clear? Above, in the above one dimensional, we are having only one dimension, then we no need to apply this, we no need to write with respect to whatever the type of axis. For one dimensional, we no need to write. For two dimensional, when we are considering the two dimensional, we have to write in what way we want to do the sort. Either one dimension, row by sorting or column by sorting. Now, after sorting, same arithmetic operations. That is, earlier we have done with respect to arithmetic operations, right? Now, A is equal to 1, 2, 3, 4. B is equal to 5, 6, 7, 8. This is one dimension. This is also one dimension array. A plus B, what is the output? Because element wise operation. The same thing. Now I'm going to do on the two dimensional. That is 1, 2, 3, 4. This is A. B is 5, 6, 7, 8. Now A plus B. What is the answer of A plus B? 6, 8. Same to same, but element wise. In this position, whatever is there in this position, the same value will be added. Just matrix adding of two matrices 1, 2, 3, 4 plus 5, 6, 7, 8. How we are going to add two matrices? Same position, right? That is 5, 8, 10, and 12. I mean 6, 8, 10, and 12. Right? Same to same. So element wise operation, it is going to do the element wise operation. Now here in this question, I'm having 1, 2, 3, 4, 5, 6. Okay, this is first row, second row, third row. This is first one. Second one is 4, 4, 4, 4, 4, 4. The output is 5, 6, 7, 8, 9, 10. This is a two-dimensional. This is a two-dimensional. This is also a two-dimensional, right? If you want to indicate with a two-dimensional clearly, if you're in the notes, if you want to write clearly, this is the first row, second row, third row. Combination of everything is a two-dimensional. First row, second row, third row, combination is two-dimensional. First row, second row, third row, combination is two-dimensional. This is the output. If you add A plus B, this is the output you are going to get. 5, 6, 7, 8, 9, 10. Square brackets in this way. Right? Next, print A into B. Now A into B. Instead of add multiplication. Same to same. Element wise. It is going to take element wise. That is 1 into 4, 2 into 4, 3 into 4, 4 into 4. And like this. For each of them, element wise operation. Here also it is going to do the element wise operation. Okay. So once again, it is going to do the element wise operation. Right? Now, sir, let us take like this, sir. There is a matrix 1, 2, 3, 4. There is one more 5, 6, 7, 8. Now, if you are multiplying, generally matrix multiplication is row and column, right? First row has to be multiplied with first column. That is called as matrix multiplication. This is called as NumPy multiplication. I'm doing the multiplication on NumPy, not on the matrix. I have not converted this one as a matrix still. So here it is a NumPy. NumPy means element wise only. In the matrices also, we can do element wise multiplication. What is that is called as? Anyone remember? In the matrices, we are having two types of multiplication. One is element wise multiplication. One is row into column wise multiplication. One is called as matrix multiplication. Matrix multiplication means first row into column. You are going to multiply that row into the column. There is one more multiplication called as dot matrix. Do you remember? A dot B. Instead of into, one is A into B. One is A dot B. A dot B means element wise. It is going to do the element wise. Here, it is going to apply the A dot B concept. Dot matrix, element wise. That is 5, 12, 21, 4, 8, 32. So it is going to give the element wise operation. No, sir, I want matrix multiplication operation. Then the function we are going to use called as matmul. Matmul means matrix multiplication is the function. Now it is going to apply the concept of matrix multiplication. That is 1, 2, 3, 4 into 2, 4, 6, 8. You are having like this. Now it is going to apply the matrix multiplication. That is 1 into 2 plus 2 into 6. This one, 2 into 6. First row is multiplied. The first row is multiplied with the first column. Again, first row is multiplied with the second column. That is 1 into 4 plus 2 into 8. Again, first row is multiplied, second row is multiplied with first column. that is 3 into 2 plus 4 into 6. Second row with second column, that is again 3 into 4 plus 4 into 8. Now that is 2 plus 2 into 6, 12. And this one is 4 plus 16. This is 6 plus 24. This is 12 plus 32, which is nothing but 14, 30, 30. Sorry, this is 20, right? And this is 44. So you're going to get output like this. If you multiply 14, 20, 30, 44. Right? So this is matmul. Matmul means matrix multiplication. Earlier multiplication, whatever you have done using the into symbol, that is element wise operation. This is element wise operation. Plus also element wise operation. So if you remember in one dimensional array also, whatever we have done, class was not completed. Don't close the books. Still two more examples are there. Okay. So plus here, whatever the plus we are doing, this is also element wise. Minus multiplication. Here, if you are doing the power plus everything, all these things are done with respect to the element wise. Everything are done with respect to element wise. Unless we write specially only, it is going to do done specially. Here also the same thing. If you do here that is equal to element wise, less than element wise, everything element wise, unless you write the special function for that, then only it is going to consider the special function. By default, matrix will take element wise only. Sorry, NumPy will take the element wise. By default, NumPy is element wise, unless you write the special function. Here you have written the special function overall to check. Otherwise, by default, it is going to do the element wise. It is not going to do overall. By default, element wise. NP dot exponential of a element wise. NP dot log of a element wise. NP dot sine of a element wise. By default, everything is element wise. Operations, every operation is done based on the element wise, unless you write the special function for that. Okay. The last concept we are having is called as concatenate, one of the most important concept. Okay. So here we are having with respect to first array, second array, two arrays we are having, array 1 and array 2. And these two arrays, we are going to do the concat. Okay. These two arrays, we are going to do the concat, means we are going to add two of them. Two arrays we are adding. If you do this a plus b, if you do a plus b, element wise operation will be done at 21 and 42, it will print. I want concatenation. String concatenation side by side, list concatenation side by side. Similarly, array concatenation. Array concatenation will be done by using np.concat. Because if you write a plus b like this, directly array 1 plus array 2, if you write like this, it is going to do the element wise operation by default. Okay. If you take a list, L1 is equal to 1, 2, 3, 4. List 2 is equal to 5, 6, 7, 8. If you write list 1 plus list 2, it is going to give 1, 2, 3, 4, 5, 6, 7, 8. It will give like this. This is list concatenation, right? String concatenation is side by side. Similarly, if you take array of 1, 2, 3, 4, B is array of 5, 6, 7, 8. If you do a plus b, by default, it is going to do element wise addition, that it is going to print 6, 8, 10, and 12. It is going to give like this. It is not going to do the concatenation. For concatenation, separately, we are having np.concat, where it is going to concat. Okay. Similarly, if you want to create a two-dimensional array, that is vertical stack, I want to create by concatenating these two one-dimensional arrays into one two-dimensional array. Then we have to use H stack or V stack. H stack means horizontal stacking. V stack means vertical stacking. Okay, sir, here whatever the vertical stacking, this is equal to your concat. If you do the here H stack, the H stack is equal to your concatenation. Okay, H stack or concat both are same. So if you are doing with H stack means both you are stacking. Stacking means attaching. Stack means attach. Horizontally you attach both of them, means side by side. Vertically you attach them. Okay, horizontal, vertical. Is it clear? One is V stack, one is H stack. Stack means attach. So that is with respect to NumPy arrays. And in the next class, we are going to discuss the pandas.